So let's do an example using the double angle and half angle identities. So the question is, suppose theta is a second quadrant angle with the sine of theta equals 12 over 13. Find these three things. I want to find the sine of 2 theta, the cosine of 2 theta, and the cosine of theta over 2. The first thing I notice is I don't have any idea what angle theta is. Who knows how many degrees or radians it is? I don't know anything about theta other than its sine is 12 over 13. So I can't just use my calculator because I don't know what theta is yet. But I can find the sine of 2 theta because the identity says that that is 2 sine theta cosine theta. That's the double angle identity for sine of 2 theta. Sine of 2 theta is 2 sine theta cosine theta. Right, so all I have to do is plug the values into that identity. The only problem is 2 sine theta is 12 over 13. I'm given that. I am not given the cosine of theta. But we practiced last week finding that. I know there's a reference angle. It's not in the first quadrant, so I'm going to look at its reference angle. Its reference angle has the sine, the opposite over the hypotenuse, to be 12/13. I use the Pythagorean theorem, whatever that adjacent side is. Adjacent side squared plus 12 squared equals the hypotenuse squared. So that's a squared plus 144 equals 169. A squared is 169 minus 144, 25. So A is 5. The adjacent side is 5, which tells me that the cosine of my angle is, in numbers, 5 over 13. But it's in the second quadrant, so the answer is negative. The cosine is negative there, and now I can fill that in. Cosine of theta is minus 5 over 13. Multiply all that. Let's see. The numerators are 2, 12, and 5. That's 120. 2 times 5 is 10, times 12 is 120. The denominators are 13 times 13, 169, and there's a 1 negative sign. So there is the value of the sine of twice my angle. If an angle has sine 12/13 in the second quadrant, twice it has sine negative 120 over 69. Cosine 2 theta. I have 3 to choose from. Right, in cosine 2 theta, I can use any of these 3 identities. I pick which one I like. I'm going to use, let's just use the bottom one. 1 minus 2 sine squared theta. Pick any of those 3. It doesn't matter. 1 minus 2 sine squared theta. So I've got here 1 minus 2 times the sine of theta is 12 over 13 squared. That's 1 minus 2 times 12 squared is 144. 13 squared is 169. 1 minus 288 over 169, which is 169 over 169, minus 288 over 169, and 169 minus 288, 169 minus 288, negative 119. Negative 119 over 169. That would be the cosine of 2 theta using that formula. So whatever theta is, its cosine is negative 119 over 169. Its sine is 120 over 169 negative. They're both negative. That tells me 2 theta is a third quadrant angle because of where its sine and cosine are. Finally, the cosine of half of theta. The formula is the cosine of half of theta. That's not it. Cosine of half of theta is plus or minus the square root of 1 plus the cosine of theta over 2, where the plus or minus is determined by where theta over 2 lives. I have to figure that out. Theta is in the second quadrant. That tells me second quadrant. That's all the angles between 90 degrees and 180 degrees. Divide this all by 2, 45 degrees, half of theta, 90 degrees. Half of theta comes between 45 and 90. That is the second quadrant. Oh, I'm sorry, that is wrong. That's the first quadrant, right? Between 45 and 90, first quadrant. So, I will choose the positive one because in the first quadrant, the cosine is positive. So this is positive square root of 1 plus the cosine of theta. 1 plus, I found the cosine of theta earlier to be negative 5/13. 1 plus negative 5/13 over 2. So that's the square root of 13/13 minus 5/13 is 8/13 over 2. That's the square root of 8 over 26. That would be the cosine of theta over 2.